guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. I am playing, man. This has been the most stressful week. You know, some people, they drink their emotions, other people eat their emotions. I'm the kind of guy that likes to work. So what we got here is a Stryker SR490. Now, the reason I got this radio is because my Connex 4400 Turbo is about as flaky as, like, I don't know, man. As flaky as a meth head that's been awake for 4 days. It gives and it runs for a few minutes and then it gets hot and then it doesn't want to do anything. So it leaves me with a gap between my 955 and this radio. So primarily I run with this radio and this radio on a workbench. Every once in a while I'll bring the D-Row radio into play. But these are pretty hard, rare unicorn horns to find. From what I understand, the difference between the 490 and the 497 is the faceplate colors. Don't care anything about the faceplate colors. Blue will suit me just fine for video cinematic purposes. This will be on the workbench here within the next couple weeks as a fixed radio with its own bird meter, its own 5-watt slug, the whole 9 yards, just like the rest of these. So there's going to be another bird meter over here eventually. I can remember a time when they gave me a hard time because I had a dozy meter, and then I had a dozy watt meter down here, and then I had a Siltronics meter up here. So I go out and I buy all these birds and get all this stuff all set up and make it standard, and then everybody copied it, and they still run around, oh, it's ghost watts. Still have no idea what ghost watts is. Anywho, first things first, this radio has got an actual final in it. Right now it's got a 1446 in the back, an actual bipolar push-pull final was what I was wanting. I was wanting to get away from the MOSFET finals of this radio and this radio. I think of this one as a bipolar because I have the MOSFET so throttled back in this radio. This radio can do like 90 watts if we cranked it all the way open, but I've got it set up for about 25-30 watts. So what I want to show you something is that power wire makes a huge difference. I was just having a debate with my friend on the phone. And yes, there is some significant amperage loss that takes place here at the plug at the back of the radio. This little 3-pin plug is woefully inadequate for what we do with it. But my argument I was having with him was that actually most of our loss is in this cable and in the fuse holder. Now, me personally, I think way back to when I was a young man and there was this crazy old weird creepy dude that was trying to skip out on child support. Lived up on top of the mountain out here. His name was Bad Habit. And so now my mom, she used to be smoking hot when I was a little teenage kid, and it was kind of creepy because all my buddies wanted to come over and hang out. Not because they wanted to hang out with me, just because they wanted to, like, check out my mom. Anyhow, he came over one time because our VCR at the time got dirty, and he offered to come over and clean the VCR heads on the VCR, and really, he was kind of drooling at my mom. But the one thing I learned from this experience is that he had jumper cables going to his 148 radio. And looking back at it now, it's kind of laughable. But what he was trying to point out to me is most of the amperage loss that takes place in your radio really isn't at this connection. Because you can remember electrically, a small piece of wire can carry a large volume of amperage over a very short distance. Okay, so most of our current loss takes place in the power wire. So this is your standard 3-pin power plug garbage. Okay, I want to show you something. 100 watt slug in 2X. So full deflection's 200 watts. Right there, it's going to be 100 watts. Right there. 100 watt slug in average, 5 watt slug in reverse. Spectrum analyzer set at 100 kcs wide and our oscilloscope. And our voltmeter is attached to this plug internally. Hello. 120 watts. Trying to give us more, but watch what's happening to the voltage. So that means all the way down here, where this plugs into some like aught gauge cable, there's 14.9 volts present. But as soon as we put it underneath any amperage load, our voltage drops way off. Way off. Okay. Now I built this cable because this is eventually going to go on the workbench, and I don't feel like changing out the power plug in the back. This is 8 gauge, soldered, shrinked to a 12 gauge plug. There's 12 gauge wire that goes into this plug. Okay. We just picked up 40 watts of output power just by changing out our power leads. So you guys need to think about that. It comes in handy, especially when you're running like a D-rail radio. He freaks out when he sees these little tiny power wires because it freaking handicaps the radio so bad. It's just there to make sure things work, so I can plug in a radio quickly if some of my buddies bring something over. But look at our voltage drop. Tenth of a volt. Point proven. So now let's look at the spectral purity of this radio. Okay. Way up here is our principal. And this is our noise floor. 79 dB, was it 70? Yeah, 79 dBm down. Okay. So we got 1, 2, 3, 4. So we got 10, 20, 30, 30 dB, 40 dB, 50 dB, 60 dB, 70 dB, 80 dB, 90 dBm down. Our principal, we actually have our side harmonics. Over here at about 50 something megahertz, we have, guess what? The radio's crystal oscillation. So we're at 70 dBm down from the top end of our principal. That is more than absolutely satisfactory for clean. Now let's look at our waveform. And that's with our mic gain all the way open, which is this knob here. No pinch, no flat top. Nothing in the negative, nothing in the positive. Okay. So now if we want to make this radio do more, what do you think we can do? We're seeing about 170-ish watts out of this thing with this little guy in here, 1446. I wonder if the amp dude has got a TO case transistor that he can stick in there. Give me a second. Well, I got a package in today. Look, twins. No, this is the one that I've been working on. This is a Stryker 490. And this is the Stryker 497 HPC. This is the same style of radio we did the 666 radio with, the 1000 watt radio. And you'll notice that there's some slight differences between the amp boards. The primary difference between the two radios is one's got a multicolored display and the other one's fixed blue. Now, I'm not going to lie, the guy that sold me this radio got this radio in the next day, and he shipped this one. And I hate to say it, but I've grown quite fond of this radio now that I've spent some time working on it, for no other reason than I spent some time working on it. But he got this radio and says, hey, why don't you do the two back to back? So the problem that we're having is with a 2290, the thing was making about 170-ish, 180 watts. So it was a couple days ago, so I don't really remember. But to you guys, it's going to seem just like one video segment ago. So we put a 2879 in here, and same amount of power, so that means not enough drive, basically. So what was in here was a Everflow 1969, which is a horrible transistor, and we changed that out to an actual 1969, and now we're doing about 100 watts. So that tells me that this is a knockoff 1969 that I acquired for someplace. So I called my friend, Mr. Zane at Big Rig Radio, and he sent me one of the very last unicorn horn transistors on the face of the earth. I rotate that around so you guys can join me in my drooling state. That is an MRF 477 that's in there, along with a bunch of assorted other 1969s in MRF 475, which is just about as good as the 477. So he says, what I do over here, I need to emulate to this one, and then I need to put a BBI sticker on it so he can send it to his customer. And I said, okay, I can do that for you. So you'll notice that there's some power input differences. This has a primary toroidal choke that goes down to the board, and then it's bonded to the board. And then this is the power lead for the amp board. But this thing here has two separate toroidal chokes for the radio, and then a separate lead over for the power supply for the amp board. Now, I've already gone around and I've done some things on the backside that I'm going to now duplicate over here. And one of the things is this trace right here. The worst designed power distribution network in all radio history is this trace right here and the trace right next to it. This is ground. They pinched the trace also here. Horribly designed. Horrible design. So how we overcome that is we just take a piece of wire and we add it to here and we bolster this power lead for the radio. We're going to definitely have to do it here since the radio on this side has got independent power supply and then the amp board. So we'll have to bolster this trace here, and then the other thing I like to do is if we get down in here and we look real close, you'll see that this trace is really small. And that's what feeds your voltage regulator. I like to boost that as well, so that way there's no current pinch point. The other thing I like to do is where the audio chip is at, I like to add a bigger capacitor than what they have in there. It adds just a little bit more electrical cushion to the situation. More cushion for the pushing would be the best way to put it. I am not a big fan of these radios. You're not going to hear me scream up and down. These style of radios, this particular style of Stryker, very busy. And we were talking, and I agree with Zane completely. The Magnums are even worse. They've got all this add-on crap on the back. And this is the way they come, like this add-on board here, and all this extra gobbledygook, and oh, we forgot to add a capacitor in the board design here. And then we roll forward about a year and a half, where they'd address some of these design issues. God knows what's going underneath this RF shield. But then once again, we've got all this other ad hoc crap that's added from the factory all over the damn place. That and these boards are really stupid thin. So I got wise to the game back when the RCI 2950 was black. Remember, it had a black body, black face? And I had one of these mounted up, well, my friend and I had one of these mounted up in his S10 pickup. And we were constantly repairing cold solder joints on the audio chip and constantly repairing cold solder joints on the PCB board, because the audio chip was right here and the board was flexing. So ever since I was about 16, I've started taking mental note of the thickness of the board. It's a very busy radio on the inside. You can see the adder boards are completely different in here, and the control units. This has got a separate board and a separate plug-in. This is part of the faceplate display, this unit here. So, I want to change that too. There's a lot of little things in here to flex, like the echo board that's in these. Man, they've got this shrunk down so small they put it on the back of the potentiometer now. Like literally right on the back of the potentiometer for the control. Whole bunch of wires coming out of the little tiny control, little tiny board. So, the other thing that we found is that this glue that's in here that they used commonly through the 80s, 90s, and early 2000s eventually turns acidic, starts eating traces, eating legs of components, and it becomes conductive. Way to go. China engineering grows stronger. They couldn't just use Celastic, they had to use wax. Or glue. So I guess this would be a glue. So, yeah, this is a wax. I couldn't use just elastic or silicone, but that's a wax. Anywho, at the end of the day, we found that this wax, just like, these radios here, like this Kenwood, with its dot pattern that they have a tendency to produce, has, in the adder control unit, or the PLL lock unit, they've got a whole bunch of glue, not glue, wax injected in there, and it eats the traces and eats the legs of the components, and that's what causes the dot issue. So, I'm going to take this one, and I'm going to hang it right here. But he told me whichever one I wanted is the one I'm going to end up with, and the other one's going to go on to the customer. And I can tell you right now, probably this one's going to end up being mine, because I've already put myself into it and a little bit of love. So, all right, on that note, I want to change out this final, and I want to see what we get for results. I bet you we're going to see a whole lot more poop out of that. And then I got to come over here and emulate this. Now, this is, like I said, the style of radio that we did with the 955 or the 666 radio with a 1,000-watt strap-on 4-pill that was on the bottom of it. And what I ended up doing with that one is I just simply changed the final from a 2290 to a 2879, and then I ended up having to take one turn out of this tank coil to make it resonant for frequency for the different load differentiation in the transistor. I don't even know if I'm going to have to do this or not, to be honest with you. It depends on how much kick we're going to get from this final. Remember, bigger final needs just a little bit more drive. So, look, they've got a little RF shield in here that they don't have over here. It's very interesting. Same test point, a little bit different filtration, a little bit different drive. Let's see, over here they've got a different set of chokes. It's got one more inductor. This has got a bridge on it of some kind. That bridge is now moved down over here. And this one has got a bunch of surface mount capacitors, where this one's got a bunch of through-board capacitors. Interesting. It's neat to see the two radios side by side, it really is. Okay, well, I'm going to quick slack on my jaw, and I'm going to go on and do other things. The other thing I wanted to point out is where they pick the RF up. It's completely different too. So picking the RF up on this side of the board, and then they run this little piece of 50 ohm mini coax. So we come over here to the same trace, there's nothing. So let's go down to the bottom side. Where they're picking it up now is from what would be normally your final output. See over here it's bypassed, and that's what these two bars are here. Those two rods. Very interesting. Huh. It's interesting. So they're bringing the RF in here. Or no, they're bringing the RF here on this board, and they're bringing the RF in here. I'm going to meter that. Alright, I'm going to go play. Let the madness begin. I shall return. Why would you call me and then ask me what the status is on your stuff, and then never, for 15 text messages, tell me what you're looking for? Even though that's the only question I've asked you. Is what I don't understand some of these guys. God, dog. Alright, so here is the 490. That is a 100-watt slug in 2X, 100-watt slug in average, and a 5-watt slug in reverse. So weird not to have to bring anything up here into play, but yeah, I just don't do a lot of radio work. Okay, let's first go over here. Now remember, we do have this mystical thing. It's called a mic gain control. So even if we do see it a little bit pinched, we'll just go ahead and make some adjustments, but I'm pretty sure we're not going to. Audio. There's our principal. And our sidebands are down, what is that, 69? 70 dBs down from our principal. So well within spec standard. About 185 to 100, well, 195 to about almost 200 watts. Way low on the bird though. And what I'm going to wait for is some upgraded voltage regulator. for this radio. This one's already, the other one's already got an upgraded voltage regulator in it. So that's where we lie with this one. It's about 200 watts. And that's with a 477 in it, an MRF 477, which is a hot final, going into a 2879. Now I was noticing on the FLIR that the pre-drive to the driver to the driver to the final, this little guy down in here, was getting smoking hot. So I took some copper and I made it a heat sink, and I wanted to support the heat sink a little bit, so if you'll see there's some double-side stick tape, and that's what's holding this in place. So that way we don't have an actual conductor back to ground over here, which we don't want to have happen. So after running this thing for a little bit, we noticed that instead of the transistor sitting there and idling at about 130 degrees, now it idles at room temperature because it's got more heat surface to dissipate the heat, so I don't have to worry about any of this breaking down. Then I did notice that this bar here on the board was getting a little hot, so I went ahead and I doubled up on it, which knocked all that out. And then we had to double down on the power wires. By doing this alone, just adding these two wires here, one for hot and one for ground, we picked up 20 watts of power. It just tells you that this here is choking it to death. This is going to work just fine for what I wanted to build it for. This one here. Now, let's do the other one and let's see what happens with it. Give me a second. Okay, here's a 497. Like I said, pretty much the only physical outward display difference is going to be that it can change colors. Whoop whoop. Alright, so let's take a look at the coil pack, the way it's sat, the way I've received it. I don't like this. Not liking this, I'm not liking this, and I'm not liking this. It's not too horribly pinched. Just turn the mic gain all the way open. Oh my god, it's a splatter box. Flat topping like a mofo. Alright. 120 watts. It's a 100 watt slug in peak times 2, so it's 200 watt slug. We're seeing about 120 watts. Remember that mark there between the 40 and the 60, that'd be 50. That's a 100 watt scale. Average power. Same as the other radio. Way less peak. Now let's look at the meter on the front. In a corner. In a corner. I think somebody turned that up to make themselves feel better. Okay, well, we're going to go in and turn this potentiometer down. Make it so it's not so chopped. And yeah, let's see how far we can take this one. Completely different board design. I think this is going to be a fun little project. Sweet. I've been looking forward to this. My new 400 gig card for my phone showed up. I'm excited. Okay, so all we did was change the ASI, DEI, whatever the fuck pile of garbage here, 2290 out. Put an actual Toshiba in its spot. Remember, 120 watts is what we were seeing before. So now we're seeing about 140. And already more bird. Yeah, now I see why I sent both radios. We just picked up, what, 10 bird by changing just the transistor. Alright. Let me play. Well, this one didn't exhibit the same heating issues as the other radio. We went ahead and reattached the mod limiter. Somebody had cut this resistor here. I'm not a fan of cutting resistors or pulling limiters, or just not a fan of it at all. Went ahead and cleaned up the coils and retightened them all back together. Not too bad. And we're 100 kcs wide. It's incredibly clean. So, about 10 watt dead key. Almost 160 watts out of this one. The problem is that we ran into the fact that this has got an RF520 in it, right here. So that limits us on how much we can shove into the throat of this thing. Upgraded the power wires going to it. Got another about 18 watts out of it by doing that. Realigned it. We're done. Now, I want to bring the other radio back over here. And I want to double test it. And then I got one more thing that I want to show you guys. And it has to go with the same theory of a mono transistor, which I think you're going to enjoy. Give me a sec. This is the radio I'm going to end up keeping here. I got a little bit more intimate feelings about this radio, and it does a little bit more wattage, but that's because it's a fully push-pull system, and I was able to really get in there and tweak with this and do more with it. So on the bench power supply, from about a 2-watt dead key, that's a 100-watt slug in 2X, by the way. Very solid 200 watts. Not pinched in the reverse or negatives or none of that other bullshit. That, and I got a mic gain knob. I know how to use it. And all the limiters are still in this radio, just like they were in the other ones. So I think this is the one I'm going to end up keeping. So I'm going to put tins on the other one. And I think it's going to go to some lucky person out there, because there's not very many people that can make their claim to fame. Oh, I got a BBI radio. Now this is what I wanted to show you. Give me a second. You guys are going to love this. Can't believe I'm going to show you guys this, but it's along the same lines of what we were just looking at. This is one of my test bed platforms that I built for when I was working with HG and them guys a little while ago, and this is probably a year and a half ago that this particular transistor that's in there now came to me through one of my friends for me to specifically test for Mr. North or Wang or whatever his name is. It doesn't really matter. And the first thing I did is I pulled out my giant Tektronix curve trace meter that I've got. Yeah, I'm going to let you guys see the inside of it for the most part. And did a gain curve leak down test on the transistor, and it displayed to me characteristics that were superior to a 2879 in little ways. But the radio that we just did, I'm literally jamming like 45 watts into a single 2879 to achieve the results that we were getting. This, like I said, is going to be a bench radio. It's never ever going to see the air, so we're going to use it for short intervals of time. The reason that this comes to light is because we're going to put almost no drive in this thing, and you guys are going to be just mind blown on what it does for power. This is a purely inductive driven circuit that's inside this amp. There is no transformers in this at all. There's no ferrite material except for right here as a choke at all in this box. This is what everybody's claiming is new. To me, it's several-year-old technology at this point. This is the 2SC2879C from HG. And first we're going to shut the amp off, and I want to show you what we're going to do with drive. We are going to hit this with the derail radio, and this is going to hurt your guys' mind. So that's a 100-watt slug in 2X. I do about 35 watts or so, right? So we're going to put a whole whopping 10 bird in it. 35 peak. And that's on 14 volts, you guys. So let that sink in for a hot second. It's 100 plus bird, 200 plus peak. Out of a single transistor. And that's not us hypersaturating the transistor either. That's just straight up 25 watts peak power, 2 watts less than its max saturation point, which is about 12 bird. Which I could probably get a couple more bird out of that thing if I'd upgrade the power wire going into it, as we just previously discussed in the beginning of this video. Old school tech to me in my mind. And who I learned this from this is nothing that I developed. I learned this from my good friend Shockwave Donald out of Connecticut, who is by far one of the most brilliant technicians that I've ever had the opportunity to learn from. He's a smart guy, patient, and willing to put up with my retardation, which is explain it to me once, explain it to me again, explain it to me the third time. And he kept telling me about this circuit. And how you achieve this is by hyper monobanding this thing. Very narrow resonance on this particular amp. But, yeah, they've now got a 2879D and I think an E and an F component. I don't know. I got them over there in the drawer. I haven't bothered messing with them lately. So, but 100 plus easy bird out of each component and 200 plus watts peak with only 10 watts of input power bird and about 35 watts peak input power on 14 volts. It's not cheating it or anything. That's straight up legit. So I thought you guys might enjoy that. Gentlemen, I gotta go. Enough playing radio tech. That ain't my job. I'm the amplifier guy and I got a bunch of stuff I gotta do. It's no joke. I gotta go sit down and start on like 4 or 5 boxes right now. So on that note, I gotta go. I appreciate you guys. Remember, we're all in this game together. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, Instagram, and of course right here on YouTube Gargler. If you like this crazy little talk show that you've seen here this evening, make sure to click subscribe. On that note, as you can hear my phone going off in the background, I gotta go get busy. I'll see you guys. Bump, bump. BBI gone.